Consider the function f of x equals x squared minus 4 over x minus 2. Which of the following statements is true regarding the discontinuity of this function? Well, let's find the discontinuity of this function. It looks like I could have either a vertical asymptote or a hole depending on what the upstairs factors to. The numerator is a difference of squares, so let's factor that. X minus 2, x plus 2, all over x minus 2. Now, since I have a factor of x minus 2 and x minus 2, one in the numerator and one in the denominator, that's going to be a hole, and that hole exists when x equals 2 because that's the number that would make this undefined. So at x equals 2, I have a hole. So let's see what our options are. Which one of these is true? There is no discontinuity. Well, that's not true because there's a hole at x equals 2. There is a removable discontinuity at x equals 2. Now, what removable discontinuity means is you have discontinuity where the limit does exist. If you have a hole, the left side and the right side of the limit exists because they are the same, which means the limit does exist. So a hole represents removable discontinuity. So B is going to be my answer. So no, not jump discontinuity, no, not infinite discontinuity, whatever that means. Maybe that's a vertical asymptote. In this case, since it's a hole, we have what's called removable discontinuity because the limit does exist.